What is HACCP, better known as HACCP? The HACCP system is a set of systematic measures used to prevent, reduce, or eliminate food safety risks. The FDA defines HACCP as a management system in which food safety is addressed through the analysis and control of biological, chemical, and physical hazards from raw material production, procurement and handling, to manufacturing, distribution, and consumption of the finished product. In the HACCP system, our goals are to identify, evaluate, and prevent, reduce, or eliminate food safety hazards. Identify. During the different stages of the production process, we identify possible hazards that may compromise product safety. Evaluate. We evaluate the possibilities of hazard occurrences and the consequences if the contaminated product is delivered to consumers. Prevent, reduce, eliminate. We identify processes to prevent, reduce, or eliminate identified hazards at each production stage. Before implementing the HACCP system, we need to establish good manufacturing procedures, GMP, and other prerequisite programs. These programs are the basis and act as a strong foundation for the HACCP program. Examples of prerequisite programs include good hygiene practices and sanitation procedures. There are 7 principles of HACCP. 1. Conducting a hazard analysis. 2. Determining the critical control points. 3. Establishing critical limits. 4. Establishing monitoring procedures. 5. Establishing corrective actions. 6. Establishing verification procedures. 7. Establishing record-keeping procedures. We will focus today's discussion on the hazard identification, monitoring, verification, corrective action, and record-keeping procedures for an identified critical control point. Hazard analysis. What is hazard analysis? In the hazard analysis step, we identify the hazards that could happen during different processing steps. Hazards include physical hazards, such as metal, plastic, glass, wood, etc. Chemical hazards, such as sanitation chemical residues, drugs, pesticides, etc. Biological hazards, such as the presence of bacteria, viruses, etc. Critical control point. What is a critical control point? A critical control point is a step in the food production process where measures can be applied to prevent, reduce, or eliminate an identified food safety hazard. Examples of critical control points could be metal detection, cooking, or cooling. Critical control points must be identified with critical limits to ensure food safety. Critical limits. What are the critical limits? Critical limits are criteria that establish the safety limits between a safe product and a potentially hazardous one. A critical limit determines the acceptability or unacceptability of the product during the process. All identified critical control points must be maintained with monitoring actions, corrective actions, and verification activities. Let's discuss some of these concepts in the next slides. What are monitoring, corrective actions, and verification? Monitoring. Monitoring is a step where we identify how we will conduct a planned sequence of observations or measurements to assess whether a CCP is under control. The monitoring must be specifically designed for the specific hazard being controlled on the processing steps. Corrective actions. Corrective actions refer to the actions taken when a critical limit is not met. Verification. Verification is a step where we confirm that employees are following the monitoring procedures. Verification also confirms that the critical controls are effective in controlling potential food hazards. Let's take the definitions that we have just learned and apply them to an example. The example for this explanation is the metal detector. Critical limits. The critical limit is no metal detectable. Metal must not pass through the metal detector undetected. So to consider the product safe, no amount of metal should pass undetected through the metal detector. Monitoring. The quality control technician performs metal detector checks every hour to ensure proper operations of the metal detector. A metal detector's functionality is usually tested at the beginning of production, every hour, before the break, after the break, and at the end of production. Corrective actions. First situation. Suppose the metal detector is not working or the check is not documented. In these cases, all products are placed on hold and rechecked through a functioning metal detector. Second situation. If metal is detected by the metal detector, all metal found is inspected to determine the source of contamination. Verification. Supervisor observes if the quality control employees are following the monitoring procedures and record-keeping properly. Performing monitoring procedures for a metal detector. This is a picture of metal detector test wands or strips used to verify that the metal detector is working properly. They contain small pieces of different metals inside. The test wands should be detected once they pass through the metal detector, when the quality control technician is performing the monitoring procedures. These next images demonstrate a way to perform the monitoring procedure. All metal detector strips must be tested through the metal detector individually. When testing the metal detector strips, the metal detector's alarm or rejection mechanism must be activated. Note: the test strips must be located approximately at the geometric center of the metal detector. Start by passing through a bag with the product without any test strip. The product must pass through the metal detector undetected. Then, we place the red test strip with the product at the geometric center and pass it through the metal detector. Subsequently, we place the blue test strip with the product at the geometric center and pass it through the metal detector. Finally, we place the yellow test strip with the product at the geometric center and perform the same process as above. The metal detector is considered functional if it detects each of the test strips. Inform your supervisor immediately if the metal detector does not detect any of the test strips or falsely rejects the product. Performing corrective action procedures for a metal detector. A metal detector may detect metal fragments through the use of an alarm and a reject mechanism. When a metal fragment is detected, stop the production line and inform your supervisor. Then place all products on hold and repass the products through the metal detector. Identify and hold products with a hold tag. Hold products in a pallet must be identified with a minimum of 2 hold tags. Next, conduct a root cause analysis to determine the reason why the metal fragments are detected in the product. What is a root cause analysis? A root cause analysis is a process that identifies the causes of problems. Based on the causes, the analysis helps to identify solutions to prevent similar problems in the future. Record all findings and the investigation on the corrective action form. And remember to record hold item details on the hold log. Note: corrective action procedures, as well as all the HACCP steps procedures, may vary depending on the policy and standards of each company. Now that we understand the differences between monitoring, corrective actions, and verification, let's discuss the concept of documentation and record keeping. Documentation and record keeping? What are documentation and record keeping? Documentation and record keeping are very important because they serve as evidence that the activity has been conducted. As we say in the industry, if it's not written down, it didn't happen. We will discuss some examples of how we monitor our pH and chemical concentration through testing activities. Here you will learn about monitoring water quality through measuring pH, determining chemical concentration through measuring parts per million. Let's learn about pH and parts per million. What is pH? pH is a scale used to specify the acidity or basicity of an aqueous solution. Measuring pH can help us understand the acidity or alkalinity of the solutions. The range goes from 0 to 14, with 7 being neutral. pH of less than 7 indicates acidity, whereas a pH of greater than 7 indicates basicity. The pH of water is a very important measurement concerning water quality. Water typically has a neutral pH, pH 7. Here we can see an example of a pH meter. The pH meter is an instrument that measures the hydrogen ion activity in water-based solutions, indicating its acidity or alkalinity expressed as pH. Follow the instructions on the pH meter. Say, we determine that the optimal pH range is between 6.5 and 7.5. Returning to the table above, we can see that a pH of between 6.5 and 7.5 is in the neutral range. What is parts per million? ppm, or parts per million, is a unit of measurement used to determine the concentration of a solution. Parts per million expresses the concentration of a given substance in a mixture. In our example, we are using a solution mixed with chemicals and water. In most cases, the chemical concentration of the chemical solution can be measured using a test strip that changes color when it is exposed to the chemical. Always follow the instructions for using each test strip kit. Comparing the color on the test strips allows you to perform a quick check if the concentration of the chemical you are using is within the requirements. Let's suppose we require a concentration of 200 ppm, and the ppm test result is lower than 200 ppm. We will need to manually add more chemical and recheck to ensure the chemical meets the requirements. If the ppm is higher than 200 ppm, then it means the mixture contains more chemical and a dilution is needed before use. Always follow the manufacturer's instructions when adding or diluting chemicals. Next, we will talk about other inspection activities. Water temperature. This image is an example of a thermometer. A thermometer can be used to measure water and product temperature. Caution. While the effectiveness of chlorine for cleaning equipment increases with heat, the chlorine compounds in food chemicals turn into toxic gas. The potential for the machine to develop corrosion also increases as the temperature rises. The scale. The scale is typically used to verify that the weight of the product meets the declared weight. It is a legal requirement that the products meet the declared weight. Example: Let's say that the bags of salads must have a declared weight of 250 grams. Procedure. First, we identify the packaging material's weight by averaging the weight of 5 packaging materials. Consider these as blank weight. Next, we repeat the above steps with a fully packaged product. These are considered gross weight. To know the net weight of the products, simply subtract the average packaging material weight from the average gross weight. Let's look at an example of how to measure product weight. First, sample 5 empty bags, also known as blank weight. Then weigh one bag at a time. Next, add up the weight of all the empty weight bags. Then, divide the result obtained by the number of bags, in this case 5. In our example, the empty bag's average weight is 1 gram. We continue by performing the same process with the packaged bags, or as they are sold, gross weight. First, sample 5 packaged bags. Then, weigh one bag at a time. Next, add up the weight of all the packaged bags. Then, divide the result obtained by the number of bags, in this case 5. In our example, the result is 252 grams. Following, we subtract the average of the empty bags from the result obtained of the average packaged product. In our example, this will be 252 grams minus 1 gram. This last result is the average weight of the product inside the packaged bags, 251 grams. The declared weight by the company is 250 grams, so the average must be at least 250 grams. It would be out of the standard if the weight of the bags averaged less than 250 grams. Calibration. What is calibration?